Hello friends, welcome to the another video of Sky's the Limit based on the topic of units and measurement. Under the units and measurement, the very important topic is the dimensions. We shall study what are dimensions in brief in this video. So here, when I say dimensions, you need to know that dimension of a physical quantity are the powers to which the fundamental units must be raised to obtain the unit of that physical quantity. So what does it mean? As I in my previous video I have explained about fundamental units. So fundamental units are the one which is independent of any physical quantity, right? Any physical unit, it is independent. That means, for example, length, we have kilogram, then we meter, kilogram, seconds, then we have Kelvin, then temperature, that is electric current, that is A, luminous intensity, candela, we have amount of substance, mole, we have. So those are the base quantities or the fundamental quantities. So here what it says, the dimensions of a physical quantities are the powers to which the fundamental units, that is, for example, we have length, mass and time. Okay, these are the fundamental quantities. Length, mass and time is the fundamental quantities. To this it have to be raised. Okay, the dimensions of a physical quantity are the powers to which the fundamental quantities must be raised, okay, to obtain the unit of the physical quantity. For example, let us I'll explain you with lots of examples so that it is very clear to you what is dimensions. So you know what are the base quantities. We have length, right? We have length and it is denoted as capital L. Always the dimension is written in the square bracket. Then we have mass, which is written as capital M. We have time, which is written as capital T. And then we have electric current, which is written as capital A. Then temperature, which is written as capital K. And amount of substance we have, which is written as mole. Then we have luminous intensity, that is candela, right? We write it as CT. So these are certain base quantities. So let us understand what is dimensional equation and what are dimensional formulas. So dimensional formula is an expression in which the derived unit of a physical quantity is expressed in terms of fundamental units is called dimensional formula. I know you didn't understand what is dimensional formula by the definition, but with the help of example it is very clear to you. The dimensional equation, we have the dimensional equation is an equation obtained by equating physical quantities. See here, example, let us start with an example of velocity. Okay, velocity. When I take velocity, what is the unit for velocity? It is displacement by time, right? We have displacement upon time. This is the unit for velocity. Now, displacement is measured in terms of meter, right? What is the unit for displacement? It is meter, and for time the unit is second, right? This is the unit for meter per second, that is unit for velocity. Now, as you know the unit for velocity, what you have to do is you have to write it in terms of dimensional formula. Like how will you write for displacement? See here, we have meter, that is meter. Meter is for what? Length, right? You represent dimensions in terms of length. So therefore this is meter. We have always, you have to write the fundamental quantities, that is MLT. That is for displacement, and write here also MLT. First step to write MLT, MLT. Then you have to see in the unit you have only meter. That means for length you don't have any mass content here. You don't have any time content in the numerator. Since you don't have any mass and time content, you raise it with the power of 0. And you have the length content. So therefore you raised it the power of 1. In case of time, only you have the time content. You don't have mass, you don't have length. So the power for mass will be 0 and the power for length will be 0. If it is 0, you can neglect the 0 powers term. What will you get here? You will get it to be this is length, and here you will get it to be t. Or you can also write it as, we don't have any mass altogether for this. We don't have any mass, we have length and we have time. This is 1. Since it is in the denominator, if it moves to the numerator, it will become -1. So this is the formula for velocity, that is m0 L t raised to -1, or you can write LT -1. This is very important formula for the dimensional equation for the velocity, that is LT -1. LT -1, you need to remember, you have to by heart it. So that is LT -1 is the dimensional formula for velocity. Let us consider another example of acceleration. First step, you need to know what is the formula for acceleration. Acceleration is rate of change of velocity by time, or velocity unit is what? Velocity is meter per second, and this time is here second, right? So therefore altogether we'll get meter per second square, right? Now you have to write the dimensional formula for acceleration. So here you can see we have meter, we have second, that is we have meter, that is length, right? And second is the unit for time. If you want to write the dimensional formula, first write the base quantities, that is fundamental quantities. Now simply you have to raise it with the powers given in the unit. Do we have any mass here? No, so it is 0. Do we have any length? Yes, of course we have meter, so it is 1, and time is -2. So therefore the dimensional formula will be LT raised to -2. Hope you have understood what is acceleration. Similarly, let us solve for force. Okay, force is what? Mass into acceleration, right? Mass, this is mass, and acceleration is what? This. So therefore you can write again in terms of m, l and t. First step, you have to write the base quantities, then you have to raise it with the power. What is the unit for force? It is kilogram meter per second square. Always write it in terms of SI system. Now here, do we have any mass here? Yes, we have the unit for mass, that is kg. So it is raised to 1. So here raise it with the power of 1. We have meter, raise it with the power of 1. Here time we have -2, so raise it with the power of -2. So therefore you will get the formula of force to be LT raised to -2. Hope you have understood how to derive the dimension for any physical quantity. This is the dimensional formula for force. This is the dimensional formula for acceleration, and we have seen also for velocity. Hope you have understood what is dimensional equation. In my next videos, we will be discussing about the application of dimensional analysis. Okay, to know what are the applications of dimensional analysis, you need to watch my next video. Okay, so subscribe to my channel, share with your friends, and hit the like button. Thank you for watching.